shielding is done by and to what types of electrons respectively? Well, one thing we need to get straight is the difference between core electrons and valence electrons. Valence, or outer electrons, are simply the electrons that are in the outermost ring, whereas the core electrons, the inner electrons, are anything inside of that, all the other electrons. Thus, without even knowing anything about shielding, you know that A and C are incorrect. But what exactly is shielding, and how can we decide between B and D? In any atom, the positively charged nucleus forms an attraction between the electrons within the atom, and here I'm specifically emphasizing the bond between the outermost electron and the nucleus. The problem is that other electrons are also competing for access to the nucleus, and by nature of their proximity to the nucleus, inner core electrons block the access of our outermost valence electrons to forming an attraction with the nucleus. Adding to this effect, these inner electrons also repel our valence electrons away, further depriving our outermost electrons access to the nucleus. As a result, the size of the atom, the atomic radius, increases because a smaller, weaker force of attraction lends to a larger atomic radius. Therefore, shielding is done by inner core electrons to valence electrons. Speaking in broad terms with periodic trends, shielding does what to atomic radius? Increases it across a period, decreases it across a period, increases down a group, decreases down a group. Well, we've just established that shielding increases atomic radius. So wherever shielding is higher, atomic radius is higher. And we can see how this works by singling out elements within the same column or group. Here we see that we add shells as we descend down a group. And the more rings of electrons we have, the more shielding that's occurring, simply because there's more layers of electrons to block the outermost electron shell from connecting with and forming a strong bond with the nucleus. Therefore, B is our answer. Shielding makes atomic radius increase as we go down a group on the periodic table with additional electron shells, so more shielding. Which of these regions on the periodic table experiences the most shielding? Well, it's not one of the top regions because with less shells, there's less shielding. The answer is actually none of the above, as both the regions at the bottom of the periodic table, 2 and 3, experience equal levels of shielding. Yet, atomic radius is bigger for elements in the bottom left as compared to elements in the bottom right, as shielding is not the only factor in determining atomic radius size. So to make sure you understand atomic radius, be sure to check out the video on your screen.